All right, folks, welcome back to 7.1, the law of sines, video number 3. So last video we took a look at this ambiguous case, and if you're feeling kind of confused, that's okay. We're going to go through a couple more examples and kind of see if we can clarify that, okay? So let's take a look at example number 4. So example number 4, it says, given that little a equals 67 degrees, a equals 100, and c equals 125, we want to go ahead and solve the triangle. And so we're going to go ahead and draw a picture, okay? So on purpose, this one has no picture with it. So I think it's really important that we also know how to draw the diagram for what goes with it. Okay, so I'm going to draw a triangle, label A, I'm going to label B, I'm going to label C, and see what information they give me. So it looks like this notation's a little bit different, but again, we got to use context clues to tell us what we have. So we see that an angle is 67 degrees, so I can fill in 67 degrees here. And if the angle is 67, then this must be the other side, so I can call this 100. And that means that this is the side opposite C, so that is 125, okay? Now, I know that we're talking about that pane in the SSA case, which is what we're looking at. So if we see our diagram, we have a side, and we have an angle that is not in between those two sides. So right away, I'm thinking SSA, and I need to check for number of triangles, all right? So this is not going to be very straightforward. I might get one triangle, I might get two triangles, I might get no triangles. So let's see. We're going to start the same way we started all the other ones, which is we're going to set up our law of sines. So sine of 67 over 100. Oh, good, I got a full pair right off the bat. Sine B over B, and sine of C over 125. Okay, so I have this as a full pair. I have no information about B, and I don't have enough information about C, but it looks like I can use A to find C. So let's do that. So number 1, find angle C. So I'm going to do sine 67 over 100 equals sine C over 125. I'm going to go ahead and cross multiply. So I've got 125 sine 67 equals 100 sine C. And I'm going to get sine C equals 125 sine 67 over 100. And let's type that into the calculator and see what we get. And so when we type that into the calculator, we get 1.151. Okay? So let's go back to our visual of the unit circle. See what we get. All right. Got my unit circle there. And sine of 1.151 means that I have a y value of 1.151, which would be like somewhere up here. Well, that's not even on our unit circle. So in this case, that is not in the range of sine, all right? It's not in the range of the sine function, so that means that there are no possible triangles here, okay? So that's one way that you know that there's going to be no triangles. You try and type this into the calculator, it doesn't give you an actual value, and that's okay sometimes. What that means, and let's scroll back up for a moment, okay? What that means is that we're looking at a case like this one. So example number 4 is like this case where the side is too short so it doesn't make a triangle. Okay? All right. So let's take a look at example 5. given that little a equals 12.7, little b equals 8.7, little a equals 12.4, little b equals 8.7, and beta equals 36.7. So let's start by drawing a triangle. So I've got one side, I've got the other side, and I've got the third side. And I'm going to label them A. I could put B here if I want, or C here. It doesn't really matter, we just have to get a diagram down. So I know that the side opposite A is 12.4. I know the side opposite B is 8.7, and this angle is 36.7. Okay? So let's go ahead and set up our law of sine. So sine A over 12.4 equals sine 36.7 over 8.7, which equals sine C over little c. All right, so full pair, no. Full pair, yes. Full pair, definitely not. Okay, so it looks like we are going to be finding angle A first. Okay, so if we try and find angle A, we've got sine A over 12.4 equals sine of 36.7 over 8.7. We're going to cross multiply, so 8.7 sine A equals 12.4 sine of 36.7. And we're going to divide, so we get sine A equals 12.4 sine 36.7 over 8.7. And that means that sine A equals 0.852. Okay, so let's get our unit circle. What does this mean? This means that I could have this angle, which has a y value of 0.852, or I could have another one, this bigger obtuse angle that also has a y value of 0.852. Okay? So I look at this and I'm like, okay, example 5 is going to be like example 3. I might get 2 triangles, and I kind of have to see. So let's do our case 1 first, and then we'll do our case 2. Okay, in case the side by side was too confusing for you for example 3, I'm going to do case 1, and then I'm going to do case 2. Okay, so case number 1. Okay, case number 1 is I just take sine of A equals 852, sorry, 0.852. I type it into the calculator and it tells me that angle A equals 58.407 degrees. Okay, so I found my A. Then step 2, I'm going to find angle C because I have all 3 angles. So 180 minus 36.7 minus 58.407 will give me an angle C of 84.893 degrees. All right, so I have angle A, I have angle C, and so the only other thing I need to find now is little c. So I'm going to use my new angle C to help me find little c. So sine of 84.893 over little c is going to equal sine of 36.7 over 8.7. I'm going to cross multiply. So C sine 36.7 equals 8.7 sine 84.893. And then I'm going to divide, so I'll get 8.7 sine 84.893 over sine of 36.7. And I'm going to see what I get as a decimal for C, and I get about 14.5. All right. So with case number 1, I was able to find all of the pieces. I found an angle A, it allowed me to find an angle C, and it allowed me to find little c. Okay. So let's take a look at case number 2 then. I'm going to squeeze case number 2 down here. Let me just get rid of this unit circle. Okay, so case number 2. Well, what if I find my angle A and I get 58.407 on the calculator, but let's say I wanted the obtuse one, or the one in the pink. I subtract that angle from 180 and I get 121.593 degrees as my angle A. All right. So let's see. Will this allow me to find an angle C? So 180 minus 121.593 minus 36.7. Does that give me an angle? And it sure does. It gives us an angle of 21.707 degrees. Okay? So because I'm able to find this, I know that there's going to be a second triangle. And I'm going to go ahead and set this up to find the little c for that other triangle. So I've got sine of 21.707 divided by little c equals sine of 36.7 over 8.7. I'm going to cross multiply, so c sine 36.7 equals 8.7 sine 21.707. I'm going to divide, so I get c equals 8.7 sine 21.707 divided by sine of 36.7, and that will give me a decimal of 5.384. Okay, so if we zoom back out, all right, then we realize that example 5 gave me the ability to find 2 different triangles, whereas in example 4 we were kind of stopped right off the bat because it was out of the range. All right, so we can write example 5 as another one that is like this. 2 possible triangles are formed. Okay, so we're gonna stop here, but come back for a very short part 4 of the video where we're just gonna take a look at this application of like when we actually use law of sines in real life. All right, I'll see you there.